Okay, in this video, we're going to talk about atomic trends, and we're going to talk about two atomic trends. The first is atomic radius, so how large the atom is, and the second is ionization energy. All right, so the first trend we're going to talk about is atomic size, and I want you to think about like the size of a ball, like a tennis ball versus a beach ball. All right, so the first way we're going to look at this is going down a group or down a column. I want to talk about what happens to the size. Well, the atomic radius is going to increase. So as you move down a column, that atom is going to get larger and larger and larger. Let's talk a little bit about why. Well, as you move down that column, you're increasing the number of energy levels, right? Your outermost energy levels. So hydrogen, its outermost electrons are in energy level number 1, right? So relatively close to the nucleus. For lithium, the outermost electrons are in energy level number 2, so they're a bit further away from the nucleus. Energy level 3 is further away, right? Energy level 4 is further away. So as you're increasing those energy levels, you're increasing the distance the outermost electron is from the nucleus. And so therefore it makes the atom larger. Now let's talk about what happens when you go across a period. So when you go across like this. Now the thing to keep in mind is that you're not adding energy levels as you go across. Now what happens to the size is that the atomic radius is going to decrease. So as you move from left to right, those atoms get smaller. Well, let's talk about why. The reason why is the elements in a period belong to the same energy level, but remember that that nucleus is getting bigger. So for example, potassium has 19 protons. Calcium has 20 protons. The electrons for both potassium and calcium sit in the same energy level, right? So technically the same distance away. But the electrons in calcium, because there's an extra proton there, they feel that pull from the nucleus more. And so it just kind of pulls them in a bit more. And so as you move across a period, you are adding more and more protons. And so it's allowing, or it's pulling those electrons in tighter, and so it makes the atom smaller. All right, the last trend we're going to talk about is first ionization energy. This is the amount of energy needed to remove an electron from an atom. And we are focusing here on a neutral atom, right? So we're not focusing on an ion, so it does not have a charge. All right, following that same trend, we want to talk about how hard it is to remove an electron from an outermost electron, right, from an atom, and what happens as you move down the group. The thing to keep in mind here, that the easier it is to remove an electron, the less energy it takes, okay? So what happens as you move down a group? Well, your energy is going to decrease. So the amount of energy required to pull that electron off is going to decrease. Let's talk about why that is. So in the previous slide, we talked about how the atoms get larger and larger and larger as you start to move down that column, right? As you are moving down that column and those electrons are getting, or those atoms are getting bigger and bigger, that electron that you're going to pull off of the atom is much farther away from the nucleus than, let's say, a smaller atom. And so the attraction that an electron has when it's out here for the nucleus is much lower, and so it's easier to remove that electron if that electron's farther away from the nucleus. So larger atoms are going to have lower ionization energies. Now let's talk about what happens when you move across a period. Now, keep in mind what we talked about in the last slide. As we move across, now remember that as you move across a period, the atoms get smaller because they feel a greater pull on those outermost electrons. That's going to make it more difficult to pull those electrons off, and so therefore we have an increase in the ionization energy. And the reason for that is, again, because that nucleus has a strong attraction to the electrons, and as those atoms get smaller, they're being pulled in. That means that that nucleus has a greater attraction on that, or a greater pull on that electron.